All right, so in trigonometry day one, or part one, whatever you want to call it, we basically just talked about angle measurements and sketching angles in standard position and coterminal angles, and then the formula for the arc length, right, which was, a portion of the circumference of a circle. Now, when we get into trig part two, we talk more about right triangle trigonometry and the 6 trig functions of angles. All right. So the first thing here is just your basic diagram of a right triangle, right? Because we're going to be dealing with right triangle trig. All right. Now, when you get into pre-calculus, you'll actually do unit circle trig, which is a little bit different than right triangle trig. I mean, it's still related. It's still the same thing. It's just looking at it from a different perspective. So we're going to deal with right triangle trig. So here's the typical diagram of a right triangle. And of course, this triangle here would be called triangle A, B, C, because those are the 3 vertices of the triangle, right? So you see how it's labeled? Angles A and B, okay, are going to be the acute angles, and angle C is going to be the right angle. All right, so you see how then we have to label it. Once we've determined that this vertex here is A and this vertex here is B, then what happens is that forces us to label the opposite sides. Little side A is opposite angle A, and little side B is opposite angle B. All right, so this is how the picture must be set up, right? So whatever vertex you have, A, for example, the side opposite that is going to be little a. And here, vertex B, the side opposite that is going to be side B. And then, of course, C, side C, is always opposite the right angle, okay? Because C is always going to be the right angle. So if you recall from, I guess, geometry class, this is a right triangle, and you know that A and B are called legs, and C is the hypotenuse, right? So you've got legs and you've got the hypotenuse, okay? And of course, the famous relationship between the sides in a right triangle is known as the Pythagorean theorem, which tells you a squared plus b squared equals c squared, okay? So this is the Pythagorean theorem, which gives you the relationship between the sides in a right triangle. All right. Again, A and B are the legs, and C is the hypotenuse. All right. So that's the Pythagorean theorem, and hopefully you recall that, or at least recall the name. Right, Pythagorean theorem. All right. So now, oh, and there was one other thing actually. That you probably covered in geometry. And the other thing that you probably covered in geometry was this idea of the sum of the angles, right? The sum of the measures of the angles. So if you take angle A plus angle B plus angle C, since this is a triangle, the 3 angles in the triangle have to add up to 180 degrees. And since C was a right angle, right, which is 90 degrees, we also knew that angle A plus angle B is 90 degrees, right? So really what ends up happening is A and B, if you remember this from the last section, are known as complementary angles, right? Because the definition of complementary was that they added up to 90 degrees, okay? So A and B are complementary angles. So that was, again, that was like really a geometry review, okay? Now, and here's where the new stuff comes into play. 6 trig functions of angles, right? There are 6 trigonometric functions of angles. And what are the names of those? They're called sine, cosine, tangent, cosecant, secant, and cotangent, all right? And how are they expressed? They're going to be expressed as ratios of the measures of sides of a right triangle. And then I define them on the next page. But the thing that you really have to keep in mind here is that these things are they're functions, right? So sine is a function, cosine is a function, tangent is a function, and so on and so forth. And of course, when you have a function, you have to have an input and an output. So in these cases, for these trig functions, right, the input is going to be an acute angle of a right triangle. So that's the input, or the x, if you want to call it x and y. So the input would be the acute angle of the right triangle, and the output is actually going to be a ratio, right, which is a fraction of the measures of sides, right, of the lengths of sides of the right triangle. So again, it's important to remember that these things are functions where the input is an angle and the output is actually a ratio, which pretty much are going to express as a fraction normally. Okay, and of course, here are the definitions. Okay, the definitions of the 6 trig functions of an angle. Right. So what I tell you is, if theta, right, is an acute angle of a right triangle, again, that's one of the inputs. The sine of theta is really the side opposite theta over the hypotenuse, right? These are ratios because they're fractions. The cosine of theta is the side adjacent theta over the hypotenuse. The tangent of theta is the side opposite theta over the side adjacent theta. And then, of course, what happens is the trig functions in the bottom row are actually reciprocals of the ones in the top row. Right? So the cosecant is actually the reciprocal of the sine, the secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. Because you see how the numerator and denominator just switch, right, as you move from the top row to the bottom row there. Okay? And of course, what usually happens here is people would give you a mnemonic device for this, and the mnemonic device that they would give you would be SOHCAHTOA. And what does that stand for? It stands for the fact that sine, right, that sine, it's opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. All right, and then you just also had to remember, of course, that the reciprocal of the sine was the cosecant, the reciprocal of the cosine was the secant, and the reciprocal of the tangent was the cotangent. Okay, so the first thing here is just I give you a triangle, right, a right triangle that has 2 sides given to you, and I say we can find all 6 of the trig functions of an angle given diagrams like this. Well, first off, it's not even labeled, right? So I'm going to go ahead and label it, I guess. I'll call this A, this B, and this C, right? Because that was my typical diagram. So if I'm labeling this triangle like this, A, B, C, that means that little a, right, little side A, is opposite angle A, so it's 5. Little side B is the thing that I don't know, which I'm going to try to find first. And then, of course, C, which is the hypotenuse opposite the right angle, is 13. Okay, so what I can do here is I can use my Pythagorean theorem. I know that a squared plus b squared equals c squared. Use this to find b. So I know a is 5, so I have 5 squared. B is what I don't know, so that's just b squared. And then c is 13, so this is equals 13 squared. And now I just solve this equation. So 25 plus b squared equals 169. Subtract 25, I would have b squared equals 144. And now we didn't technically do this yet. We do this in the second unit, but this is known as square root principle. If I want to solve for something that's squared, I can just take the square root of it. And the square root of 144, of course, is going to be 12. So now I have all 3 sides of my right triangle, right? I know a is 5, b is 12, and c is 13. So I can just write 12 here. All right. So of course, now that I have all 3 sides, I can find the trig functions of the angles, right? So let's say I want to find the sine of A, right? So again, look at SOHCAHTOA. Sine is going to be opposite over hypotenuse. So here's side A, right? So what's opposite A? It would be 5. And of course, the hypotenuse is always going to be 13. So the sine of A would be the opposite, which is 5, over the hypotenuse, which is 13. And then the cosine of A is going to be the adjacent over the hypotenuse, right? This is the k part of SOHCAHTOA. So when I'm doing cosine, now I look at the adjacent, right, next to, the side next to A, which is 12, over the hypotenuse, which is, again, still 13. So the cosine of A would be 12/13. And then the tangent of A is going to be the opposite over the adjacent, right? O over A. So the side opposite A was 5, and the side adjacent A was 12. So the tangent of A is 5/12. The cosine of A was 12/13, and the sine of A was 5/13. All right. So those are the three basic ones, right? That's what where SOHCAHTOA comes from: sine, cosine, and tangent. And now if I want to do the reciprocal ones, so the reciprocal of the sine was the cosecant of A. And instead of remembering like a definition of cosecant, right, as being the hypotenuse over the opposite, just think of it as the reciprocal of the sine. So cosecant is really the reciprocal of 5/13, which is just going to be 13/5. Right? And then the secant of A is going to be the reciprocal of the cosine. So if the cosine was 12/13, the secant is going to be 13/12. And then, of course, the cotangent of A is going to be the reciprocal of the tangent, which would be 12/5. All right? So again, the thing to keep in mind was these were just reciprocals. Right? This was the reciprocal of this. This was the reciprocal of this. And then this was the reciprocal of this. Okay? So that would be the 6 trig functions of angle A. So we've done the 6 trig functions of angle A, but I think I would be remiss if I did not also do the trig functions of angle B, right? Because if we recall, in the definition of these trig functions, we said the input can be either one of the acute angles in a right triangle, right? So all I did was the trig functions of A, but I could have also done the trig functions of B, right? So I could have also asked for the sine of B instead of the sine of A, and the cosine of B instead of the cosine of A, so on and so forth. So here what happens? My definition is still the same, right? Sine is still the opposite over the hypotenuse, but in this case, I'm looking at angle B. So now, when I'm looking at angle B, the side opposite angle B is actually going to be 12, right? And the hypotenuse is still 13, right? The hypotenuse is never going to change. It's always going to be 13. But what happens is, when you're dealing with angle B now, 12 becomes the opposite, right? Whereas when you were looking at angle A, 5 was the opposite. So you have to realize what happens there is the opposite and the adjacent switch when you switch angles, right? So the cosine of B now is going to be the adjacent over the hypotenuse. So the side adjacent B is right there, which is 5, over the hypotenuse, which is again 13, okay? And then, of course, the tangent of B is going to be the opposite over the adjacent. And again, the opposite was 12, and the adjacent was 5. So it's going to be 12/5. Okay? So there's my trig functions of angle B. And then, of course, I could do also cosecant, which would be the reciprocal of the sine, you know, secant, reciprocal of the cosine, and cotangent, reciprocal of the tangent. Okay? But I don't have space A and B. I don't think it's really necessary. Just remember, you know, that they're just reciprocals. But another thing that you should probably notice here is the sine of B and the cosine of A were the same, right? and also the cosine of b and the sine of a were the same. And it should probably be kind of clear why that happens because of what we said before, right? Remember how the opposite and the adjacent switch? So the side that is opposite A is actually adjacent to B, and the side that is opposite to B is actually adjacent to A, right? So right there you can see why the sine of B was equal to the cosine of A, and the cosine of B was equal to the sine of A. And then the same thing works for tangent and cotangent, right? The tangent of B was the same as the cotangent of A, right? And the tangent of A is going to be the same as the cotangent of B, right? Because again, the idea is that the opposite and the adjacent sides just switch when you look at the other angle, right? So if you switch angles, the opposite and the adjacent switch. But again, remember the hypotenuse never changes, right? So in this case, the hypotenuse was always 13. It's just that the opposite and the adjacent would switch when you were dealing with the two different angles, okay? So that would be the 6 trig functions of the angles of a right triangle.